Chapter 11, Section 5, Areas of Circles and Sectors. The area of a circle theorem says that the area of a circle is pi times the square of the radius. So area is going to be equal to pi times radius squared. This first example asks us to find the area of the circle with the given information. A asks us to find the area of a circle with a radius of 3 meters. Because they've given us the radius, I can just go ahead and plug in 3 to my formula. So the area would be pi times 3 squared. Well, 3 squared is 9. So my area is going to be 9 pi. If they were asking us to leave it in terms of pi, I would say 9 pi meters squared. But since they didn't say leave in terms of pi or not to leave in terms of pi, I'm going to go ahead and multiply 9 times 3.14, which is about 28.26 meters squared. Example B tells us that we have a diameter of 18 feet. We can only plug in the radius to the formula to find the area of a circle. Because they've given us the diameter as 18 feet, we're going to use that to find the radius. If the diameter is 18 feet, the radius is going to be half that, so the radius is going to be 9. Now I can plug in 9 for r, so I have pi times 9 squared. 9 squared is 81. Again, if they wanted me to leave this in terms of pi, it would be 81 pi feet squared. Since they didn't tell us which one they wanted us to do, I'm going to go ahead and multiply by 3.14, and we get 254.34 meters squared. That should be feet squared. Sorry, I didn't change my units. So we really quickly need to define a sector of a circle. A sector is going to be the region bounded by 2 radii of the circle and their intercepted arc. So if you look at this diagram, I have sector AZB. It's going to be enclosed by ZA and the radius ZB and then the arc AB. So the purple highlighted area is enclosed by my 2 radii, ZA and ZB, and then the intercepted arc AB. The area of a sector theorem says that the ratio of the area A of a sector of a circle to the area of the circle is equal to the ratio of the intercepted arc to 360 degrees. This is very similar to what we talked about in the last lesson when we were finding the length of an arc. Now we're finding the area of a sector, and we can say that A, which is the area of the sector, over pi times radius squared. Notice pi times radius squared, that would just give us the area of the entire circle, is going to be equal to the measure in degrees of arc AB over 360. This next example says, find the area of the sector shown below. We know that the radius of this circle is 11 meters, and they also tell us that the central angle is 135 degrees. Because my central angle, angle YXZ is 135 degrees, we know that the measure of arc YZ is also going to be 135 degrees. So we can plug in what we know to the proportion, and we can say capital A, remember that represents the area of the sector, over pi times 11 squared, because the radius is 11, equals 135 over 360, because this intercepted arc is 135 degrees. You can go ahead and cross multiply, or you could also just think I need to get A by itself, so I would need to multiply both sides by pi times 11 squared. When I cross multiplied, so I have 360A equals 121 pi times 135. 121 is 11 squared. I went ahead and in the next step I left 360A equals, I multiplied 121 times 135, which gives me 16,335 pi. I need to divide both sides by 360, and when you plug it into your calculator, you should get around 142.5 meters squared. I'm talking about the area of a sector, so I need to make sure that in my answer I'm putting my units squared. This next example says L and M are 2 points on circle R with radius 50 centimeters, and the measure of angle LRM is 150 degrees. Find the areas of the sectors formed by angle LRM. First thing, I'm going to go ahead and draw a diagram. I already have a circle on this slide. The center is R, and it tells me I have 2 points, L and M. I'm going to go ahead and draw in my radii. They told me that the radius is 50 centimeters. They also tell me that this angle measure is 150 degrees. Really quickly, we're going to have to find the area of the circle. Remember, it's going to be the area of the sector over the area of the circle. So I'm just really quickly, before I start setting up my proportion, I'm just going to go ahead and find the area of the circle. So it would be pi times 50 squared. Well, 50 squared is 2,500. So I have 2,500 pi, which is about 7,854. So when I set up my proportion, I can say A over 7,854, which was the area of the entire circle, equals 150 over 360. Cross multiply, and then divide both sides by 360, and you find the area of this sector is about 3,272.5 centimeters squared. What I can do from here, I have two different options. I could always set up another proportion to find, because it asked me to find the area of the sectors formed. Notice this was my smaller sector formed, but notice there's also that it would kind of look like a Pac-Man. The other part of this circle that is not in that sector, LRM. So what I can do now, I could set up my proportion and do the whole thing all over again. Instead of, I would still have A over 7,854 equals, instead of 150, I would have 210, because that would be the measure of the other angle LRM over 360. Or I know the area of the entire circle, and then I know the area of this sector, 3,272.5. What I can do is I can take the whole area and subtract the smaller sector, and then I would be left with the area of the remaining sector. So that's a little bit faster and easier. That's what I'm going to go ahead and do. And I would find that that second sector would be 4,581.5 centimeters squared. That makes sense. They need to add together to equal your whole area. And then it also makes sense because they should be fairly close together. They're only 30 degrees off from each other. However, the second sector should definitely be larger than my first sector that I found. This next example says find the area of the shaded region shown at the right. Notice in this shaded region, I have a circle, but then a triangle, and it's an equilateral triangle, has been taken out of the circle. What I can do here is I need to find the area of both the circle and the triangle, and then to find just the area of my shaded region, I would need to take the area of the circle and subtract the area of the triangle. So the circle's area is going to be fairly easy to find. It tells you that the radius is 4, so the area of the circle would be pi times 4 squared, which is 16 pi. You could go ahead and multiply that out, or you could leave it as 16 pi for right now. The area of the triangle is going to be a little bit trickier. Notice I do not know a side length here. I do know it's an equilateral triangle, and I do know that the radii of that equilateral triangle is 4 centimeters. What I'm going to be able to do is if I draw in this side right here, it's going to create a 30, 60, 90 triangle. What I know about this 30, 60, 90 triangle is that the hypotenuse is 4 centimeters. Because I know the hypotenuse is 4 centimeters, I know that the smaller leg is 2 centimeters. Remember, this is one of your special right triangles. And then because I know the shortest leg is 2, I can know that the longer leg is going to be 2 square roots of 3. You have to be really careful here though, because 2 square roots of 3 is only going to be half the length of the entire triangle's side length. So 2 square roots of 3 is only the length of from my 2 centimeter side coming down, my shorter leg, to the 30-degree angle. It's not including that second half of the base of the big triangle. So the base of the whole triangle would be 4 square roots of 3. And what I've done is I know that if I draw the radii from the center of the circle to the top, that's going to be 4 centimeters. So 4 centimeters from the top angle to the center plus the 2 centimeters created by that line that I drew in my shorter leg is going to have a total height of 6 centimeters. So to find the area of the triangle, I would have 1/2 base times height. Half of 6 is 3, so 3 times 4 square roots of 3 is going to give me 12 square roots of 3. To find the area of just the shaded region, I need to take the area of my circle, which was 16 pi, and subtract the area of my triangle, which was 12 square roots of 3. Go ahead and you can plug this into your calculator, and when you do, you would get about 29.5 centimeters squared. This next example says you are cutting the front face of a grandfather clock out of wood as shown in the diagram. What is the area of the front of the case? Again, I have a shaded region here. Notice I have 2 shapes. Both of them look like rectangles with a semicircle added to the top of them. What I can do to find the area of the outer region is I can take the area of the rectangle plus the area of the semicircle, and that would give me the area of the entire shape. And then I would have to do the same thing for the inner shape, and then I would have to subtract them. So really quickly, to find the area of the outer region, first of all, I know this full side length would be 80 because it's 80 inches because it's created by the 70 inches, and then 10 inches is added at the bottom. So 80 times 42, which would be the width of this clock, would be give me the area of the rectangle. The area of the semicircle, be careful because it is a semicircle, so when I find the area, I need to divide it by 2 or take half of it. I'm talking about the outer circle here, so be careful. We know the diameter of the outer circle is 42 inches because that's the bottom length. That would be the same at the top, so we need half of that, which would give me 21 inches. So I need to add 21 squared times pi divided by 2. 21 squared pi is going to be the area of the circle. I only need half of it, so that's why I've divided it by 2. And when you plug that into your calculator, you should get about 4,052.7. Now I need to do the same thing, but now I need to find the area of the inner rectangle. The area of the inner rectangle, the white rectangle kind of in the center, notice it would have a height of 70 inches. And then its width is going to be the diameter of the circle. It tells us that the radius is 11, so the width would have to be 22. That would give you the area of the rectangle. And then then I would need to add, to find the area of this semicircle, it tells us that the radius is 11. So I would have 11 squared times pi, and then divided by 2 again because I'm only adding half of the circle. And then when you plug this into your calculator, you should get about 1,730.1. What I need to do is I need to subtract the area of the larger shape minus the area of the smaller shape. And when I do so, I get about 2,322.6 inches squared. This next example asks us to find the area of the shaded region. Notice I have 2 circles here that have been kind of cut out or taken out of a rectangle. I need to find the dimensions of my rectangle. In order to do so, I'm going to have to use the radii and diameter measures of the circles. Notice here, my height of this rectangle, or my width, would be 16 inches because that would be the diameter of the circle. And then these 2 circles put together would give me my length. Each circle has a diameter of 16, so when we put two circles with the diameters of 16 next to each other, it's going to create a 32-inch side for my rectangle. So to find the area of my rectangle, I would just multiply 16 times 32, which is 512 inches squared. And then I need to find the area of the two congruent circles. Each one would have an area of pi times 8 squared. Well, 8 squared is 64, so each one would have an area of 64 pi. But because there are two of them, I need to go ahead and multiply it by 2. So I'd have 512, the area of my rectangle, minus 2 times 64 pi, which 64 pi is the area of one of my circles, but since there are two, I need to multiply it by 2. When I subtract, when I multiply 2 times 64 pi, I get 401.92. Go ahead and subtract these and you get 110.08 inches squared. This last example is kind of just a challenge problem. It says find the area of the countertop. Notice this countertop has been kind of sectioned off for us. We're going to have two rectangles, and then we kind of, at the center, we kind of have a like a square looking thing, but a fourth of a circle has been cut out of it. And then at the very bottom, I have a semicircle. And what I need to do, what I'm going to be able to do, is find the area of each of these four parts, and then I would need to add them together to find the area of the whole countertop. So let's just do that really quickly. I'm not going to spend a lot of time going through this. Like I said, it's just kind of like a challenge problem. Let's find the area of this rectangle first. Notice it is 1.15 feet wide and 2 feet tall. So to find the area of a rectangle, you just multiply base times height, length times width. In this case, it's going to be 2 times 1.5, which is 3. So the area of this rectangle is 3. Next, let's find the area of this. It looks like a square, but it's got a quarter of a circle cut out of it. What I need to do here is I'm going to find the area of this whole square, but then I'm going to subtract the area of my quarter circle. Each of these, this square has a side length of 3.5 because we have the 2 feet side plus the radius of the circle is 1.5. So I have 3.5 times 3.5 is 12.25. But then I need to subtract the area of the quarter of a circle. So what I've done here is I've taken 1.5 squared times pi, which would be the area of the full circle, but then I divided it by 4 because this is only 1/4 of that circle. When I do that, I get about 1.8. I need to subtract those two areas, and I get about 10.45. So that would be the area of this square with a quarter circle cut out. The area of this rectangle, thank goodness, it's just a rectangle, is 10. 2 times 5 is 10. And then the area of this semicircle, notice this semicircle is going to have a diameter of 2 because it's sharing a side with the rectangle. If the diameter is 2, that means the radius is going to be 1. And I only have half of the circle. So what I'm going to do here is I'm going to have pi times 1 squared and then divided by 2. And that would give me 1.57. So now to find the area of the entire countertop, I'm going to take all of these pieces and add them together. And when I do so, I get about 24.92 feet squared. How they charge you for a countertop is how much of the material you use. So this would be a real-life application to use this. Some companies will charge you based on how much you actually use, and some companies will charge you on how much they had to spend and cut from. So it just kind of depends, but that would be the area or the amount of material you used for this countertop. Today's assignment is on page 695. It's numbers 4 through 20 even and 36.